Now for this lesson, we have Delta Math as the main part of the lesson. This is kind of a warm-up activity. And then on Delta Math, if you weren't in class, there are extra help videos made by Delta Math that you could watch for the different question types you have. It's day 2 for transformations. We have a transform function. The first thing we want to do is identify the parent function. So I'm actually going to do that first. My first one is f of x equals x plus 6. I recognize this is linear. There's nothing special going on. So my parent function, and I'm just going to use y equals here, is y equals x. Now this one is actually kind of tricky because we can't see the parentheses, and because linear functions are so simple, they're just straight lines, it actually could be two things. So I'm going to take this as x plus 6 and say that this goes up 6, shift up 6 is the answer. But I could also, it would be equivalent if I put the whole thing in parentheses and I said that it went left 6. And actually, if you think about a graph, a line moving left 6 from the origin, right? It goes through the origin right now for the y-intercept. Moving it left 6 would actually put the y-intercept up at positive 6 on the y-axis. So they end up being the same thing. I know that's a lot, but that's really the only one where there's multiple options. So moving on to the next one, 5x squared minus 1. I see the x squared, so the parent function is a quadratic x squared. Two transformations happening here. We want to do the one that involves multiplication first, kind of with PEMDAS. So the first thing that I would say happen is a vertical stretch. You can abbreviate them, that's fine. I don't know, extra letter in there. Stretch of 5. And then this minus 1 is definitely not in parentheses with the x squared, so that's down 1. The next one is a cubic parent function. So that's x cubed. There's only one transformation. I'm going to say that negative sign is in the front where we see it. It's not in parentheses. So that's making the function negative, not in parentheses with the x. So that's a reflection in the x-axis. So this to me is negative f of x. In essence, if you simplify in parentheses negative x cubed, it is the same thing as this, but that's what I see in the notation. So the next one, our parent function is the square root of x. The transformation that occurred here, the plus 7 is in the radical with the x, so that is left 7. Definitely, it's not outside where the up 7 would be. Next one is also quadratic, so y equals x squared. So that's going to go, this part would go right 4 and up 6. And those two wouldn't really impact each other, so you could really write them in either order. I just chose to write them from left to right. The next one is another square root function. So the number on the outside, that's a vertical stretch. I keep writing an extra C. Okay, I know how to spell the word stretch. No C before the T. And then that's of 3. And the negative on the x in parentheses is a reflection in the y axis because x is becoming negative, f of negative x, that's what's going on there. The next one is absolute value. And you should definitely, pretty much if you haven't already, try to do all of them and then check because that'll be how you get your practice. So this is first in the parentheses. That's going to be right 4. And then outside of the absolute value is down, so down 8. Now, for some reason, I basically can't move it. The writing is not staying with the page. So I'm going to pause the video and erase the whole thing, but make sure you have it all down. So here on the bottom of the page, this is another one where the parent function is linear. We have a 1/2 multiplied by the function, that's a vertical compression. of 1/2. The next one is one we don't see quite as much. This is the cube root function. So that's cube root of x. If you look at your parent functions a couple pages back, in the last lesson, you'll see it there. And the only change that we see is the adding to in the actual function. So that's going to be left 2. The next one has 3 different changes. And I do know in class there'll be like people that say, how do I tell what's the transformations and what makes the parent function? And it's really knowing your choices for parent functions. So I know these type of things can be transformations, but an x squared, that creates a whole different shape of a graph, right? A parabola versus a straight line or something like that. So that's the part that's the parent function. So I'm going to start with the multiplied part. I'm going to start with a vertical stretch. So I'm going to abbreviate. This is vertical stretch of 3. In the parentheses is -1, so that's going to move right 1. And at the end is +1, so that's going to move up 1. So those are our 3 transformations. The next one also has a lot going on, but I see my x cubed, which I know makes a specific type of graph, it's a specific shape, so that's my parent function. I'm going to start from the outside. I really actually have 4 things going on here. So the first 2 are kind of interchangeable because they're in the same spot. So the negative sign in the front of a function is going to make it reflect in the x-axis. Right, it's not on the x in the parentheses with the cubed, it's in the front. The 2 in the front is a vertical stretch of 2. The +9 is left 9. And then the -4 is down 4. Now in delta math, you're basically going to have a parent function graph, and you're going to have a dotted line for some sort of transformation, and you have to make changes in different spots to the function so that basically the parent function moves over to where the transformation is. So it's very connected to this, as I said, if you need to watch the video, and we will be doing this in class unless for some reason you're at home.